Now we move to the final major technical part of today's lecture: future trends in petroleum data analytics. This slide emphasizes real-time monitoring, smart decision-making, and enhanced safety through intelligent systems. This is where the industry is heading. The future is not only about collecting more data. It is about using data faster, more intelligently, and more safely. Real-time monitoring can help detect abnormal events early. Smart decision systems can support optimization. Intelligent systems can reduce downtime, improve efficiency, and enhance operational safety. This slide introduces generative AI and a concept labeled Petroleum GPT, emphasizing that AI and large language models can help streamline reservoir simulation workflows. This is a very exciting frontier. Generative AI is different from classical predictive ML. Instead of only predicting numbers, it can interpret documents, summarize technical knowledge, explain workflows, assist with model building, and answer natural language questions for you, my student. This means future petroleum engineers may interact with simulation tools and data platforms in much more intuitive ways. Instead of searching through manuals for hours, engineers may ask technically guided questions and receive structured assistance. Of course, this still requires validation, but the productivity potential is enormous. This slide outlines 3 central tasks in reservoir simulation: getting the model right, implementing the model accurately and efficiently, and optimizing model parameters. It also notes that history matching is the key process for matching model outputs to observed data. This is a great slide for you because it shows exactly where AI can help. AI may assist in history matching, in input preparation, in parameter screening, in identifying inconsistent settings, and in helping engineers explore alternative scenarios faster. So the role of AI is not only prediction. It can also act as an assistant across the workflow. This slide outlines 3 central tasks in reservoir simulation: getting the model right, implementing the model accurately and efficiently, and optimizing model parameters. It also notes that history matching is the key process for matching model outputs to observed data. This is a great slide because it shows exactly where AI can help. AI may assist in history matching, in input preparation, in parameter screening, in identifying inconsistent settings, and in helping engineers explore alternative scenarios faster. So the role of AI is not only prediction. It can also act as an assistant across the workflow. This slide provides a more detailed implication workflow, accessing a domain-specific reservoir simulation knowledge base, tokenizing knowledge into a vector database, using LLM guidance to build physically consistent input files, running simulations in a high-performance computing environment, processing results, and returning them to the user for natural language queries. This is an impressive vision of the future. Notice how many steps AI can potentially touch: knowledge retrieval, model setup, execution support, results interpretation, and user interaction. The petroleum engineer of the future may work in a hybrid environment where physics-based simulation, cloud computing, and generative AI all operate together. This slide suggests the idea of a chatbot for reservoir simulation. That may sound futuristic, but it is actually becoming realistic. Imagine a system where an engineer can ask, "Why did this simulation fail?" or "Which well control changed between these two runs?" or summarize the difference in pressure behavior between case A and case B. A well-designed technical chatbot could save enormous time, especially for training younger engineers and supporting complex workflows. This slide gives a remark about AI, and this is a good moment for balance. AI is powerful, but it should be used responsibly. In petroleum engineering, AI should support decision-making, not replace engineering judgment. You should understand that petroleum engineering remains a physics-based and risk-sensitive discipline. AI can accelerate analysis, improve pattern recognition, and help organize knowledge, but it must be checked against engineering reality. The best petroleum engineer in the future will not be the person who uses AI blindly. It will be the person who combines AI with deep domain knowledge. This slide summarizes the main learning points: where data come from, the types of data in each phase of the oilfield cycle, machine learning for petroleum data analysis, and generative AI for reservoir simulation. Let us restate the big message of today's lecture. Petroleum engineering is a data-driven discipline. Data come from every stage of the field life cycle. Conventional methods remain important, especially seismic interpretation, log analysis, well testing, modeling, and decline analysis. Machine learning is opening new opportunities for faster interpretation and prediction. Generative AI may further transform workflows by integrating knowledge, simulation, and natural language interaction. So petroleum data analysis is not a side topic. It is one of the central capabilities of the modern petroleum engineer. This slide tells us that the next topic is the role of carbon capture and storage for future generation petroleum engineering. That is actually a very fitting next step. Many of the ideas we discussed today, data analysis, simulation, machine learning, and intelligent workflows, are also directly relevant to CCS. So the next lecture will show how petroleum engineering skills can contribute to a lower carbon future. That brings us to the end of today's lecture. Thank you very much for your attention. I hope today's lecture helped you see petroleum engineering from a broader perspective, not only as drilling and production, but as a data-rich engineering discipline where interpretation, modeling, analytics, and decision-making are all deeply connected. If you have any questions, I would be very happy to discuss them with you.